with the way. I saw you press it, but it hasn't opened all the way up yet.
Okay.
But the you know, the little your little dashboard, yeah, I can see everything. I can see the full window. Your little dashboard, we can't really see that, so don't worry about if that's getting in the way. And you can.
No, I've hidden that.
That looks great.
Okay, so this web page is from the Landscape Decision Support Tool site. It's part of the community portal. Do you see my mouse move there in the part that I'm highlighting?
Yeah.
Okay, so the community portal is also linked here on the top. So I encourage you to have a read through that at your leisure, and lots of other topics, and certainly feel free to comment and add your own content. So a quick reminder on why we need to normalize. I guess one of the strengths of multi-criteria analysis is the ability to combine all different types of data as long as you can measure it on a numeric scale. But in order to do that, it has to first bring them to a common scale. So that's what normalizing is all about. I'm going to jump over now to ArcGIS and work through a real simple example. So this is intended to sort of be 101, and I guess apologies to people that have been working in this area for a while, for whom this is second nature. So this is a very hypothetical data set with just 4 cells. So typically in multi-criteria decision analysis in the GIS environment, you would use a raster or a gridded set of cells covering your study area. And in this case, our input raster, you can see in the table of contents on the left, has values of 2, 4, and 8. So if you want to think of those as some kind of measurements or monetary values, or we're going to convert them to a normalized scale, and Landscape Decision Support Tools encourages a 0 to 1 common scale. Another layer that we're going to use is this one of the study area. So in this case, all of the input cells have been given a value of 1, and we'll see in a minute. Why that's necessary. So jumping back for a minute to this normalization backgrounder, there's kind of 2 common procedures out there for doing normalization, and you can see a link down here to PDF. So that's the Malczewski, a scan of some of the pages from the Malczewski reference book and maximum score. It may be referred to as other things, but that's his terminology, so we're sticking with that. And as you can see, the formula is a simple take each value and divide it by the maximum value. So in terms of doing that in the raster environment in ArcGIS, I'm first going to show you one of the important input pieces, and for that we're going to use map algebra and build up a real simple expression, and it's called zonal max. And the idea of zones in raster is to provide summary type statistics across one or more zones. So in this case, we're dealing with our entire study area as the zone, but in fact you could have multiple zones for other types of analyses, but in this case we're just looking to get the maximum value for the entire study area. So we're going to pump in that study area layer, and in fact I will use this pick feature, so I can do a drag and drop. So what we're asking for is to go through all cells in the study area and find the maximum value from this input raster. So looking over at our input raster, we expect the output from this to be 8. Do a quick run. How are the screen refreshes coming? Is everyone seeing all black now?
Yep. Yeah.
Okay. So we can see from the key on the left that all 4 cells have now been converted to a value of 8 to the max. Okay, so in terms of using that for this maximum score procedure, I put together sort of a simple version of a custom tool to accomplish that. So we're quickly going to look at the design for that. Inputs again being your study area and an input. I've made those parameters, so in fact you could make that any layer. And within the custom tool, we'll have a quick look now at the map algebra. So here's the expression we just ran a minute ago, which returns the maximum value. And what we're doing then is taking the value for each cell and dividing it by that max. So in other words, we're implementing this simple formula, but the thing to remember about the raster environment is that it's doing it for every cell. So when we say use the input raster, we're saying run that calculation for each cell in the input raster. So we'll close this and open up the tool as an end user would see it. So I've already filled in the layers that I want to use, but again, you could pick other layers to use. So now when we say, and this is the output layer we're going to create, so now when we say go, and I'm just going to change the symbology quickly to show the unique values from that output. So now we see that the 4 cells have been normalized. Just remind you of what the underlying input layer looked like before we normalized it and after normalization. So we can see the cell that was an 8 scored the highest in a normalization, became a 1. The cell which was half of 8, which was 4, became a 0.5 is the medium color here in the top right. And the other 2 cells, which started out as a 2, are now a quarter of that max, are 0.25. The other sort of common normalization approach out there is called the score range procedure. And the interesting thing about that, about the score range procedure, is that it guarantees that the output is going to be in the 0 to 1 range. So in other words, it will make your lowest value 0 and your highest value 1. And there are a number of cases and reasons why you might want to use the score range versus the maximum score procedure. So I'll just quickly show that one in action. So again, I've pre-built a custom tool here, and the only thing different now is the actual expression we're using. Let me go to the simple sort of version of it first. Right here. So it's called the score range because the denominator is the max minus the min, so it's taking the range of all possible scores. And then the numerator is value minus the min. And we'll sort of see the significance of this visually now in ArcGIS. So again, this is, looks a little more complex here, but you have to remember it's performing these calculations for every cell, not just for a single value. So it's taking our input value. Here's the equivalent function called a zonal min, which determines the minimum of all values in our study area. And then the denominator is the max minus the min. So if we think about our input data for a second, the max was 8, the min was 2, so the range of values that's going to be used in the denominator for that math is now 6. So if we go ahead and run that, and let me just quickly change the display properties to show the unique values. So now we see our highest cell, which started at, let's go back to the original for a second, so that's the original input. Our highest value cell started out as an 8, has become a 1. That's in the bottom left. The lowest value, which started out as a 2, has now become a 0. And the 4 in the top right has become 0.33. And the way to think about that is if our range of values is 6 from 2 through 8, then 4 is 1/3 of the way along that range of numbers from 2 to 8. So visually we can kind of see the difference. The max score normalization, the lowest value was not 0, and in the score range normalization, their lowest value has become 0. Any questions?
Well, Randall, I think one question you might be, maybe we can all get to a discussion about it at the end, but one of the things we're going to want to do is all be on the same page as to when we should use one versus the other and why. But we can discuss that after you do the next thing, I think. Okay,
sounds good. One caveat to note, so our input data set did not have any zeros as input values, but if there was a 0 present in the data set, then score range and max score actually provide the exact same results. And in our recent experience using the landscape decision support tools with the Islands Trust in BC, for most of our layers, so if you think about something like protected areas, so we had a layer that rated the protected areas for their quality. So each of the cells within a protected area had a score, but those outside the protected areas were given a 0 score. So after normalization, they retained a 0 score, and everything within the protected areas had a normalized score greater than 0 up to 1 for the highest quality protected area. For those experienced in doing using vector as opposed to raster in GIS, it's also noteworthy that you can do these calculations for vector polygons and then convert things over to raster. Some people also may be familiar with the raster calculator, but not with map algebra.